Well, hello again out there in remote learning land. Today's hot topic, pun intended, talking about air masses, how they travel the globe, how they affect weather, and it's pretty wild. You can see these thermal images here showing different temperature blobs around the Earth. Well, those are blobs of air. We call them air masses, and they migrate, and wherever they go, they bring their characteristics with them. So that's what we're jumping into today. I'm going to start out with normally we start out dressing a couple of students up as different air masses, and we have some fun moving them around the room and showing how they would influence the weather and that. But anyway, I found a decent clip. It'll explain and give you good visualizations of what's going on with these moving blobs of air around the Earth that we call air masses. All right, check it out.
Air masses. Objective: to learn the 4 types of air masses. An air mass is a huge body of air, so large that it often stretches for several thousand miles. Air masses generally have similar temperature and moisture properties throughout. The geographical location from which an air mass originates is its source. The types of air masses formed on Earth are determined by their source region. Air masses can have one of 4 qualities: continental, maritime, tropical, or polar. Continental air masses occur over large land masses and usually contain less moisture than other air masses, meaning they tend to be dry. Maritime air masses originate over a large body of water and are also known as oceanic air masses. Because they form over water, they are moist. Tropical air masses form in regions of lower latitudes and are usually warm. Polar air masses form over polar ice caps and are very cold. As these air masses move across Earth's surface, they will change, becoming modified according to the characteristics of the location beneath them. For example, an Arctic air mass with very cold and dry air moving across the ocean will become warm and moist, changing over to a moist maritime polar air mass. When this polar air mass moves south from Canada into the southern United States, it will acquire warmth from the ground below and become drier due to a lack of moisture. This air mass has now become a continental polar air mass. When air masses stay long over a region, they control the weather of those regions.
And over continents like this, we find air masses that are relatively dry. Several major air masses affect our weather in the United States. Maritime tropical air masses, forming over the oceans near the equator, are warm with a great deal of moisture. During the summer, these air masses usually result in rain. But in the colder months, the precipitation could be snow.
In the northern Pacific Ocean and in the North Atlantic, we sometimes find maritime polar air masses. During the summer, these air masses in the Pacific usually mean fog along the west coast. In the east, they often result in cooler temperatures. But in the winter, these polar masses from the oceans can produce heavy snow and sometimes even blizzards. To the south, continental tropical air masses form over Mexico during the summer, bringing hot, dry air to many states in the United States Southwest. Finally, continental polar air masses form over northern Canada, resulting in very cold winter temperatures in parts of the northern United States.
Okay. This is an interesting little picture here. It kind of shows you the outlines of the regions and where different air masses would form. All right. One thing you should realize is that as an air mass moves to another region, it doesn't change right away. It kind of hangs on to its characteristics for a while. So that an air mass coming down from the Arctic By the time it gets to Elmont, yes, it's changed a little bit, but that's when we get those winter cold bursts, in the teens, because, air masses are these giant, giant blobs of air, so they don't change their characteristics that quickly. And as it comes down, it's going to hang on to those characteristics for a while. Yes, ultimately it will warm up, but that does take time. Just like in the summertime when we get those crazy heat waves, right? 90, 95 degrees and crazy humid. Well, what do you think caused that? A maritime tropical coming up from the Gulf of Mexico, right? And as it, moves slowly up towards Elmont, it's still bringing that heat and humidity with it. And those heat waves can last for, several days to a week because it takes a long time for that blob of air to get out of there. Okay? Okay. So anyway, read this through. Hit pause if you got to. How do we define air masses there? Okay. There's your official definition. Make sure you get it in there. A large parcel of air that has characteristics based on temperature and humidity. Source region is where it comes from. And of course, that will determine its temperature and moisture. Okay? All right. Here's a chart. I want you to try to fill in on your own here. All right, continental, maritime, tropical, polar. It goes through, of course, the name of the air masses. Let's see if you can figure out their source regions, the symbol they use, temperature, and characteristics. All right, so hit pause, take a minute, fill in what you can. All right. So for the first one, of course, continental is over land. The symbol is C. This, of course, is describing an amount of moisture, a humidity, and if it's continental, it's dry. And, of course, there it is, dry. Dry air tends to be denser. That dry, cool air is very dense. All right. Maritime, you probably figured out in the name there, right? Marine, marina, over water. The symbol, of course, the first letter of the word M. This, too, is describing an amount of moisture or humidity. And, of course, this would be a very moist air mass. Tropical, well, you probably figured near the equator, right? Lower latitudes. Again, the first letter is a T. This is describing a temperature this time, however, right? It's warm in the tropics. And, of course, that would be warm, less dense air, which is going to rise up. Polar, as you figured, toward the poles, right? Definitely higher latitude origin. It's a P, certainly describing a temperature. And, of course, that would be cold. But the granddaddy of all cold air masses is the Arctic. And we don't get these that often, usually once a winter. We're talking about crazy extreme latitudes. A is the symbol. It's still a temperature, but this time it's the coldest air of the winter. And that's what we said before, that cold snap that you'll get once, maybe twice a winter, where the temperature is in, could be the single digits even. Okay? All right, so that's that chart. Hit pause if you need it. Going to keep moving on. All right. This is the chart in your reference tables in case you forget the name of air masses. They're all there. It's on the right by that other weather data chart as well. Okay, page 13 in the reference tables. This chart here, again, I'm going to put the symbols down here. Now we combine them. Hit pause at this point and try to fill in the rest of the chart on your own. Okay. Double check your work. Hopefully for CA you realized it was continental Arctic, CP continental polar, CT continental tropical, and of course MP maritime polar there with all of the characteristics. All right, so I hope you did all right on those. Obviously, if you're still confused or have any questions, certainly as we meet up in the chat, we'll go through those. Okay. At this point, start cranking on your summary activity. You got to figure out which air mass would be in the blobs here, right, coming from its source region. So just write in those two letters to name it. And then you have a couple of region summary questions that follow. All right, I'll meet you back in a meet.